Hi, in this video I'm going to show you guys 5 examples of finding the indefinite integral. Okay, so first of all, what's indefinite integral? In the previous video, we learned how to find integrals, and we learned that we will always have a plus c. Right? We will always have a plus c at the back. So let me just bring up the notes that we had. So we will always have a plus c, and over here this is my plus c, right? So all of them are called the indefinite integrals because the c can be any constant, right? So it is not a definite. We don't know exactly what is the exact integral. So because the c can be any value, so we call them the indefinite integral. All right, so that it is just a big word. So basically, indefinite integrals are integrals with a plus c at the back. All right, so there's always like a something, that's your integral plus c. Okay, so this part, when you see that, that means it's indefinite integral. Okay. Now let's take a look at the examples. So for part example A, they want us to find the indefinite integral of x to the power of 6. So I'm going to integrate x to the power of 6 with respect to x, right? So the thinking process that we have would be, so this is, I need to bring this up a level, which means the power should be 7. Right, so when I differentiate this x to the power of 7, I drop the power by 1, I'll get x to the power of 6, right? But at the same time, the 7 is going to come forward, so I need to make sure that I have a 1 over 7 to take care of that, to plus c. So again, if you try to differentiate what we have here, so say y is equal to 1 over 7, x to the power of 7 plus c, and plus c is just a constant. If you dy dx, right, so this will be 1 over 7 multiply 7 x to the power of 6. And if I differentiate this constant, it becomes 0. So 7 to 7 cuts out, I get x to the power of 6, which is what I have over here. Okay, now that's it. All right, so my answer, my indefinite integral for my A is 1 over 7 x to the power of 7 plus c. Now for B, there's I need to integrate. I need to find the indefinite integral of 4 with respect to t. Now, I don't have x anymore. In this case, my variable is t. So what did I differentiate? Right? What did I differentiate? I differentiated something, and that gave me a 4. So what's that something gonna be? I differentiated something that gave me a 4, so that something has to be 4x, right? 4x plus c. Now, if your answer is 4x, your answer is actually wrong, because right now my variable is t. So make sure that you stick with the variable. So in this case, it will be 4t. Right? So if my y is equal to 4t, and then dy dt, I'll get 4, which is what I have over there. Okay. Now that's it. Now let's look at example C. In this case, I'm finding the indefinite integral of 3x to the power of 5 with respect to x. So before I get to, so in order for me to get an x power of 5, my integral should have x power of 6. Does that make sense? And then if I differentiate this, I need to move the 6 to the front. So for me to take care of that, I need to have a 6 down there. But since I want to have this 3 there, so I'm going to leave that 3 there, and this is going to be plus c. So if I simplify this, I'll get half of x to the power of 6 plus c. So let's see if this makes sense. So y is equal to half of x to the power of 6 plus c. dy dx, remember that plus c is just a constant. This will be half multiplied by, if I bring the 6 down, that'd be multiplied by 6, multiplied by x, 6 minus 1, that gives us 5, if I differentiate the plus c, I get 0. This is 1, this is 3. I get 3x to the power of 5, which is what I have here. Okay? So my answer is good. Right. So for part C, it is a little bit tricky, right? But all we are doing here is we're trying to find the integral. And when we do that, we're thinking, okay, what should I differentiate to get what we have over here? What should I differentiate to get what we have, what I have in the boxes? Okay. So I'm gonna spend a little bit more time on example C. So the first step I did was to find the power, right? That's the first step, because I know that when I differentiate this, the power has to drop by 1, so I get 5. That's good. But the thing is, if I differentiate this x to the power of 6, I'm going to have a coefficient of 6 in the front. Right? I'm going to have a coefficient of 6 in the front. So by having this denominator, that will take care of it. Right? That will take care of it. And also this 3 is just basically what the 3 that I have there. Right? So that's kind of the thinking process that that you should have when you are finding the indefinite integrals. Okay, so I'm going to put down the 1, 2, 3 in terms of the first thing I need to think of is the power, and then I need to think about the coefficients. So to take care of the coefficients, I need to have this denominator. And right now I have a 3 up there. They want us to have a 3, so that I'm going to have a 3 there, right? Okay, now I got 2 more examples for you guys. All right, so these 2 examples are a bit longer. Okay, they're a bit longer, but the logic behind it is the same. So let's do part D first. We need to find the indefinite integral of this whole thing. Right? It looks scary, but all we are doing here is we are trying to integrate 1 by 1 by 1. Okay, we're trying to integrate them bit by bit. So, and then the variable that we have here is u. So we're just finding the indefinite integral of all this with respect to u. Okay, so in order for me to get a u to the power of 4, then I must differentiate something that has a power of 5. Does it make sense? Right? And if I differentiate this, I'm going to get a 5. But right now I want a 3, so I'm going to have 5, and I have 5 in the denominator and 3 in the numerator. Okay, and then plus. Now this is u squared. So in order for me to get u squared, I must differentiate something with the u cube. And when I do that, if I differentiate this, I'm going to move the 3 down, right? And that 3 is going to multiply by something to give me a 6. So that something has to be a 2. Does that make sense? Okay. Now finally, what do I differentiate so that I get a 2? So I hope your answer is 2u. If I differentiate 2u, I'll just get a 2. And don't forget, since we're finding the indefinite integrals, this plus c, we need to have it there. Okay, so let's try to differentiate what we have here and to make sure that our answers are correct. So let's say y is equal to 3 over 5, u to the power of 5 plus 2u cubed plus 2u plus t. dy du, my variable in this case is u. I'll get 3 over 5 multiply 5, and the u is going to drop by 1. So I have u to the power of 4 plus 2 times 3. Right? 2 times 3 multiply u to the power of 2, u squared, plus 2. And if I differentiate the c, it becomes 0. So the 5 and the 5 cancels out. I get 3u to the power of 4. 2 times 3, that gives us 6, u squared plus 2, which is what we have over there. So that's good. Okay? Now let's take care of the last one. Now for the last one, I'm going to change the way it looks a little bit. So we're going to find in the indefinite integral of x plus cube root of 3. Cube root of x, the whole thing with respect to x. So what I'm doing here is I'm going to change the way it looks a little bit. X plus, this is x to the power of 1 over 3. Right? So x cubed can be written as x to the power of 1 over 3 with respect to x. Now the first one is not bad. In order for me to get an x here, I must start with something with a 2. right? And if I differentiate that, I'll get a 2 in the front. But right now my coefficient should be 1, so I'm going to have 1 over 2 in the front. So the first one is done. Now the next one, plus. Okay, what should I differentiate so that I get x to the power 1 over 3? So I'm going to differentiate something with 4 over 3, right? Because 1 over 3 plus 1 gives us 4 over 3, right? So I'm going to have this. However, my coefficient right now is 1, right? So, but if I differentiate this, this is going to come down, and I won't get a 1, right? So I need to make sure that I multiply the reciprocal of that power. So I'm going to have 4 over 3. And finally, the plus c. Okay, so let's just check if this is right. So y is equal to half x squared plus 3 over 4 x to the power 4 over 3 plus c. And if I dy dx, I'll get 2 goes down, so half times 2 times x. The power is going to drop by 1, so I only have x there. Plus 3 over 4. Multiply, the power goes to the front, so you have 4 over 3. And then x, 4 over 3 minus 1, that will get 1 over 3. And then the plus c becomes 0. So the half and the 2 cancels out. I only have x. 4 and 4 cancels out. 3 and 3 cancels out. I will have plus x to the power of 1 over 3, which is what we have there. Okay, so this is good. So my final answer for both, my final answer is this. Make sure you have the plus c at the back. And for my d, that is my final answer. All right. Don't be scared by this name, the indefinite integral. It is just the plus c. Okay? All right, I'll see you guys in the next video. Bye.